Yeah, welcome back to KISH CAT classes. I hope that you have watched the introduction video of circles. In that video, I've clearly explained the relationship between angles, straight lines, and then circles. If you haven't watched it, please watch it and then come back. This session is completely dedicated to the worksheet I have sent to you. If you haven't solved it, please solve it and then resume this video. If you are yet to receive the worksheet, please do mail me at kishcatclasses@gmail.com, or else you can download the official Facebook page of KISH CAT CLASSES, facebook.com/KISHCATCLASSES. Once you solve, come down. Now, before I discuss with you, remember the most important things related to CAT is like one is chord, tangent. We focus on these two things exclusively. Majority of the CAT questions are completely related to chord and tangent. Now, let's solve question number 1 of worksheet. This is the worksheet. From a point outside a circle of radius 15 cm, two tangents are drawn to the circle. The angle between the tangents is 74 degrees. Find the area of the triangle formed by the tangents and the chord joining the points of contact. Here, sin 37 degrees is given as 0.6 as the value. So, from an external point, two tangents are drawn to the circle whose radius is 15 centimeters. Now, we need to find the area of the triangle formed by the tangent and the chord. So, it's clearly given. Now, we are going to solve question based on chord and tangent. First question. From a circle, that is like two tangents are drawn. The radius of the circle is given as 15 centimeters. So, this is 15 cm. And this angle is given as 74 degrees. Now, what is the relationship between a chord and a tangent? The angle made by the radius at the contact point of the tangent is 90 degrees. Now, it is clearly given as 90 degrees. Now, we need to find the triangle formed by the tangent and the chords. Now, one angle is given 74 degrees, and we already identified that the angle is 90 degrees because the angle between tangent and radius is 90 degrees. Now, if you draw a straight line, now look at this one, O, let's say AB, and this is also contact point C. Now, OAB is a right angle triangle. Right angle is 90 degrees. One angle, that is angle A, is bisected by the line OA. It means that this one is bisected. This one is 37 degrees. This part is also 37 degrees. Now, you know only one side of the triangle and you know the two angles also. Then how will you find the area if you know only one side? Focus on it. You can still find one more side because the value of sin 37 degrees is given. Now, if you observe that OAB right angle rectangle B, you can write sin A degrees is equal to opposite side by hypotenuse. What is opposite side? OB. What is hypotenuse? OA. Now, what is the value of OB? Sin 37, A is 37 degrees is given. Sin 37 is 0.6, that is equal to OB by OA. So, OA is clearly given as 15. So, it means that OB is equal to, OB is given, in fact, OB is given as 15. So, OA, now you can find OA equal to 15 by 6. So, OA is how much? It is coming as 25. So, now OA is equal to 25. Now, you can find AB just like that, because OAB is a right angle triangle. OA square is equal to OB square plus AB square. OA square is 25 square, that is 625, is equal to OB square, which is 225, then AB square. Then AB square you can find as 20. So now the length of the tangent is 20 degrees. What is the question? The question is, what is the find the area of the triangle formed by tangents and the chord joining the points of contact. Look, now one more thing has come. We need to find the area of this triangle, that is like ABC, the area of the triangle. Now how will you find the area of the triangle? Is fairly simple. We know AB length as well as AC length. AB length as well as AC length. Now we know angle A also, that is a sine 74 degrees. We have no idea about sine 74. Sine 37 is given as 0.6. Sine 74 is sine 2 into 37, that is sine 2a. Sine 2a formula you can use it actually. But however, you still have one more option. What is BC? So if you know the length of BC, then it is simple. Now how can you find the length of BC? It's very simple. Let's say this contact point is called D. What is BD? What is BD? Now what is OA? OA is a straight line started from center point. Now what is CB? CB is a chord. So chord makes exactly 90 degrees. It means that DB equal to DC. Now observe this in a triangle OAB. BD is the altitude. Now you can find the length of that altitude, that is half into dB into OA, which is area, is equal to half into OB into BA. So what is dB? No idea. What is OA? It is 25. So half into dB into 25 is equal to half into 15 into 20. What is AB? AB you can find because it's a Pythagorean triplet. So how much? dB? dB is 12. Now this is 12. So it means that CB is 24 centimeters. Now we know three sides, which is 25, 25 and 24. Now three sides are there. You can find the area by using formula, that is S into S minus A into S minus B into S minus C. Now you can find it on your own. Observe this one. We used properties related to tangent, chord and radius. Okay. That's all. Question number 2. In the figure below, not to scale, PQ is a chord of a circle. O is the center of the circle. PQ, that is chord, is extended to R such that QR is equal to OQ. OR is produced to meet the circle at S. Find angle PRS and then angle POS. Just you need to find angle POS. First, draw a straight line from P to O. Just draw a straight line. So you need to find the relationship between angle PRS and then angle POS. How can you find? No angle is given. So you just need to compare the angles. Now how will you compare the angle is we need to find at least one more information. It is clearly given that OQR is equal to OQ. Now OQ means just draw a straight line OQ. What is OQ? OQ is a radius. Again, look, we are trying to use radius only. Radius, secant. So OQ is radius. OP is also radius. It means that OPQ is an isosceles triangle. So angle P is equal to angle Q. So if you take that angle P as x degrees, then angle Q is also x degrees. Angle P, angle Q, both are x degrees. What is angle OQ? So can you identify that OQ is angle Q is an external angle. So external angle you can write as 180 minus x degrees. This angle you can write as 180 minus x degrees. Now then what is this angle? X by 2. That angle is equal to x by 2. This angle is also equal to x by 2. So this is x by 2 because it is clearly given that OQ equal to QR, x by 2 degrees. This angle is also equal to x by 2 degrees. Now what is PRO? That is x by 2. Then how can you find POS? Just focus on it. Just identify POS. How can you find POS? What is POS? If you identify it, it is an external angle of angle POR. Angle P is known as x degrees. Angle R is known as x by 2 degrees. It means that this is x plus x by 2 degrees. This angle is x plus x by 2 degrees. Now, what is the relationship? How can you find it? That's it. Angle PRS is x by 2 degrees. Angle POS 3x by 2 degrees. So then how much? 1 is to 1 by 3. Look, it's just like that. You can find it. External angles. We have used the secant. We have used OP, that is radius. So every triangle, every circle-based question, almost all the questions are completely based on chord, tangent, radius. Now, let's focus on this one. So, before you read that information given in the question number 3, you can identify that AB is a chord, OC is a radius. So, the moment you observe this one, you should be able to understand what is the relation between radius and the chord. What is the relationship? A chord is bisected by radius if the radius passes through the midpoint of the chord and it is going to be perpendicular. Now let's observe, let's read the question number 3. In the figure given below, not to scale, O is the center of the circle, OC is perpendicular to AB. So if it is a perpendicular to AB, then it means that it is bisected chord AB. EC is given as 8 centimeters. AB is equal to OC plus 12 centimeter. AB is chord. So chord is OC plus 12 centimeters. So OC is radius. That is called radius plus 12 centimeters. ED, D is a point on chord AB and ED is equal to 3/4 of EB. Find angle ODE. So we need to find angle ODE. So how can we find angle ODE is fairly simple. We need to identify angle O, then we can find angle D easily because we know that angle E is already 90 degrees. Just draw. Now identify how to find angle ODE. Angle ODE, it is clearly given that ED equal to 3/4 of EB. So it means that you should identify a relationship between chord by using radius, by using some other aspects. So now EC is given as, just focus on whatever given, just write. EC is equal to 8. OE is not given. You can imagine that OE as x. So it means that radius is 8 plus x. What is AB? AB is radius plus, that is OC is radius plus 12. What is radius? X plus 8. So AB equal to x plus 8 plus 12. So AB is equal to x plus 20. X plus 20. Now let's focus on how to find the length of EB. I know that EB is half of the chord AB. The chord length is clearly given that x plus 20 degrees. Now it means that EB equal to x by 2 plus 10 degrees plus 10 length. Now I know EB is x by 2 plus 10. I know OE also. So now I know two sides and I know that this angle is E. How can we find OB? What is OB? OB is radius if you observe it. Now this is OB. What is OB? OB is radius. OB is what? Exactly x plus 8. So this is x plus 8. Now you can find that what is the value of x actually. X plus 8 whole square equal to x square plus x by 2 plus 10 whole square. Right angle triangle. Hypotenuse square equal to side square plus side square. Now you can find x. The moment you find x, then you can find the value of ED, because ED is 3/4 of BC. But once you find this one, it is difficult to find angle O still, because we have no idea about what is angle O. We don't have any idea about angle EOD. After finding this one, I think you are going to get a triangle which is 45, 45, 90 or 30, 60, 90 degrees triangle. Otherwise, it is not at all possible to find the relationship between angle O and angle D. The sum of angle EOD and EDO is 90. But how to find? Then focus on finding x, then you can identify whether the given triangle is 30, 60, 90 degrees or not. Just observe this one. We are not trying to use any other thing actually. We are trying to use the radius, the chord and the relationships. And quite often we get only 30, 60, 90 degrees triangles in CAT or 45, 45, 90 degrees. We haven't, I haven't seen a single question based on other than these standard angles. Let's observe question number 4. If you have solved this one, question number 4. Question number 4, there seems to be a lot of lines, chords and chords only. So it's going to be based on chords, radius, the simple thing. In a figure below, the diameter is 12 centimeter. PQ and RS are the diameter. So it's clearly given that PQ and RS of the circle and are perpendicular to each other. So it means that they are meeting at a 90 degrees. So angle, this angle is 90 degrees. PT is to TQ is clearly given. What is PT is to TQ? The PQ is a diameter, so PT is to TQ is given. And the diameter is given as 12. So PT is to TQ is 1:3 means PT is going to be 3, TQ is going to be 6. So this PT is 3, TQ is 9. However, you know that OQ is already 6 because OQ is the radius. It means that you know that OT is also equal to 3, and then you know that OQ is equal to 6. Next one, RU is to US is also 1:3. What is RU? What is RS? Diameter. RU is to US is 1:3. It means that RU is 3, and you can still find that UO is also 3, and then this one is also 6. O is the center of the circle. Find XY. Find XY. If XZ is if XZ is parallel to VW. If XZ is perpendicular, what is given is like the symbol has appeared in a different way. XZ is perpendicular to VW. Now, what should you need? You know the radius, you know the length of OU, you know the length of every side XY and YT also. So, only you need to identify the lengths. So, find XY. What is XY? XY is one part of the chord. How can you find the XY? It's very simple. Just draw a straight line meeting X and O. What is OX? OX is radius. How much is radius? 6 centimeters. How much is OT? 3. How much is XT? 6 square minus 3 square. 36 minus 9. 27. So XT is root 27. That is 3 root 3. So now we got that XT is root 3 root 3. Now how much is YT? YT is equivalent to OU. How much is OU? It is 3. So YT is 3. XT is equal to how much? 3 root 3. YT is 3. It means that 3 root 3 minus 3. So 3 into root 3 minus 1. The answer option A. Observe these one things. Every information is clearly given, and then by using that information, you can find a right angle triangle where the hypotenuse is radius and the other two sides are given. Okay, let's focus on question number 5. C1 and C2 are the two concentric circles with center O. Now, you must know what is concentric circle. Chord AB of the outer circle C1 touches the inner circle C2 at C. X is a point on the minor arc AB such that X is perpendicular to AB. If XC is given as 4 cm and BC equal to 8, find OB. The moment you read half of the information, do not proceed, because the remaining part is all about lengths of the sides. So first construct one. C1 and C2 are two concentric circles with center O. So one circle and then second circle. The centers are equal. So this is C1, this is C2. Chord AB of the outer circle C1 touches the inner circle C2 at C. Chord AB, so it means that this is the chord AB, it touches the inner circle at C. So it means that AC or BC is a tangent to C1. One second, I am just clearly moving on it. Chord AB of the outer circle C1 touches the inner circle C2 at C. X is a point on minor arc AB. So we have already drawn such that XC is perpendicular to AB. So we need to draw XC. So this is XC. This is perpendicular. Now the lengths are clearly given. Focus on them. XC equal to 4, BC equal to 8. So XC is 4, BC is 8. Now what should you do? Then find OB. What is OB? What is OB? Yeah. So you need to find radius. Now how will you find the radius here? You just have to focus on it. Just focus on it. Radius, chord and other things are given. You need to find that OB, radius. Now how will you find the length of the OB is fairly simple. You should have a triangle to find it out. Otherwise, see, length of a line, you cannot find it directly by observation. You should have a triangle, then you can find the length. Now what is OB? OB is radius. What is OC? What is OX? Radius. What is OC? Yeah, R minus 4. This is R minus 4. How much is CB? It's clearly given as 8. Now you can find this triangle actually. This is a triangle, right angle triangle. One side is R minus 4, other side is R, other side is 8. So R square equal to R minus 4 whole square plus 8 square. Look, the information is clearly presented there. You just need to identify, you just need to apply it actually. Now let's focus on question number 6. In the figure given below, OE is the center of the circle and AB is the diameter of the circle. DE is the tangent to the circle at C. Find angle BCE if angle ABC is given as 50 degrees. So this angle is clearly given, which is 50 degrees. Now, what is the use of AB? AB is clearly mentioned that it is a diameter. So if it is a diameter, you can take AB as a segment. The segment AB makes exactly 90 degrees at 180 degrees at the center O. So this is 180 degrees. So it means that it makes exactly half of it. It means that it is 90 degrees. So if it is 90 degrees, you can say that O angle A equal to 40 degrees. Now what is angle A? What is the relationship between chord and tangent? Yeah, alternate segment, the angle. Now it means that the angle between chord and the tangent is equal to the angle made by the same chord on the opposite side of the segment. So it means that this is also equal to x degrees. So that's what asked, right? BC, that is also x degrees. That is means it is not x degrees, it is equal to 40 degrees because these two are equal. So observe these things. We are going to use chord, tangent, radius to find the areas. Now just focus on question number 7. AB and CD are two chords of a circle with center O. The line AB and CD intersect outside the circle at P. Line PO cuts BD at E, which is its midpoint. So if it is a midpoint, what is the line actually? OP. OP is a line passing through the center. If it cuts BD at the midpoint, it means that it makes exactly 90 degrees with the chord BD. So angle E equal to 90 degrees now. Now read the question. Line PO cuts BD at E, which is the midpoint. OA is equal to 5 centimeters. So this is what? This is 5 centimeters. And OP is 13 centimeters. What is the ratio of the distances of AB and CD? So we need to find what is the ratio of distances of AB and CD from O. So from the center point of the circle, we need to find the distances to two lines, that is CD and AB. How will you find them? Just focus on it. You are going to get it. What is the use of 5 and what is the use of 13?
Length of PD square equals to DO into that 5 centimeters.
Length of
PD square equals to.
Concentrate on it actually. It's a fairly simple thing. What is OA? OA is a radius. Radius is clearly given. You can find that OB is also radius. This one is also radius. OC is also radius. OD is also radius. So everything is radius only. So the radius is 5 centimeters. Observe this one carefully. We don't need any external information. OAB triangle, OCD triangle. Focus on it. OAB triangle, OCD triangle. Actually, OA equal to OB, OC equal to OD. What is the angle actually? Well, OAB, OCD. Can we prove that these two triangles are similar triangles? How can we prove? Yeah, OAP is equal to OCP. It means that angle A equal to angle C. Yeah, simple actually. So just focus on it actually. Angle OAP is equal to OCP. OC and OA are equal. OP is common. One angle is common. Side, angle, side. One side is OA, which is correspondent to side OC. One angle, angle A, which is correspondent to angle C. And then another straight line AP, which is correspondent to CP. It means that two are similar triangles. Then heights are equal, right? So it means that the distance from O to a line AB and O to line CD are in the ratio 1:1. So similar triangles. Next, question number 8. Two circles touch each other internally at point C. CD is the diameter of the bigger circle. Chord AB of the bigger circle is perpendicular to CD and the tangent to smaller circle. AD equal to 4 root 5, AC equal to 8 root 5. See, the moment you read this question, this question is all about diameter, tangent, chord. So look at this one. A circle question, it is very difficult for a circle question to stay away from one of these properties: tangent, radius, chord, secant. Two circles touch each other internally at a point C. So just draw two circles. Circle 1 and then circle 2. It touches this one at C. Here is this question at C. CD is the diameter of the bigger circle. So it means that you just need to draw. This is CD. This is the diameter. Chord AB of the bigger circle is perpendicular to the CD and the tangent to smaller circle. That's it. It is clearly given. There is a chord. So this is the chord AB perpendicular to CD. So exactly, it means that this one is, I can write this as E. Oh, its chord is also bisected. AE equal to AB, clearly given. Now just write down the remaining properties given. AD equal to 4 root 5, AC equal to 8 root 5. What is AD? AD equal to, this one is 4 root 5. AC is, this one is 8 root 5. Yes, how will you find it now? And how will you find EC? One is given as 4 root 5, other one is given as 8 root 5. What is CD? CD is the diameter. Do you remember? CD you can take as a segment. The segment makes 180 degrees at the center and it also makes 90 degrees at the circumference. So identify this one. This one is 90 degrees. So now you can find the length of CD just like that. 8 root 5 whole square plus 4 root 5 whole square is equal to DC square. So 8 root 5 whole square means 64 into 5, 320 plus 4 root 5 means 16 plus 8. 16 into 5, 80, that is 400. So DC square, DC equal to 20. So we know that this length of diameter is 20. Now once you know this 120, you just need to find the EC. How can you find EC? Is fairly simple. You should know what is AE. AE is clearly given as tangent to the circle as well as, yeah, look at this one. It's a right angle triangle angle. E is right angle. So I know that area of the triangle is half into 4 root 5 into 8 root 5 is equal to half into CD, CG which is 20 into AE which is height. How much AE? AE comes as 8. AE comes as 8. So if you know that it is 8, then you can again find EC, because EC again it's a right angle triangle. So 8 root 5 whole square minus 8 square is equal to EC square. 320 minus 64. 320 minus 64 is equal to EC square. How much is 64? 256. So EC square equal to 256. So EC equal to 16. So that's it. All you need to identify is like CD is a segment actually. So that is called diameter. Then you can find that angle A. Angle A is 90 degrees. Once you know angle A, you can find the area. Once you know area, you can find any side. Every single time, focus on the concept that you have already learned. Chord, segment, angle made by the segment at the center is twice the angle made by the same segment on the circumference. Again focus on tangents. Again focus on chords. That's all the question number 9. Just go through question number 9 again. Go through question number 9. Now solve question number 9. There are 3 unit circles intersecting each other as shown in the figure at point M and and O, which are the centers of the circles. Find the total length of arcs MN, NO and OM. So it means that we just need to find the lengths of these 3 things. Now try to use the information given in the question statement. We know that the radius is 1 centimeter and we need to find the whole thing. Well, at MN, NO and OM, if you observe all of them carefully, they are not straight lines, they are arcs. If you observe arcs, it means again M and O, these 3 are given as centers also. So if you draw, so this is the center. From the center to this point, it is 1 centimeter. This point is 1 centimeter. If you use OA as a center, so OM and then ON, all these are 1 centimeters. So if you observe all of them, the inside it is an equilateral triangle with 1 centimeter as the side. You need to find NO length, MO length and then OM length. How will you find? It's a simple thing. It's an arc with 60 degrees. It is an arc with 60 degrees. And then there are 3 arcs like this. It means that 60 degrees arcs are 3. Or else you can directly find 180 degrees arc. 180 degrees is semi-perimeter. Semi-perimeter of a triangle with radius 1 centimeter. That is what you need to identify. So semi-perimeter is half into 2 pi r. R is 1. So that is pi. Pi units. Just focus on what is given. So question number 9 is a simple one. Just you know that MN equal to MO and you know that OM equal to ON. It means that MNO is an equilateral triangle with angle 60 degrees. So if it is 60 degrees, you just have to find what is ON. How can you find ON is? It's an arc. So you can find it out. Now let's focus on the next question. In a triangle, PQR is an isosceles triangle with area 4 centimeters. And look, without reading the remaining information, it is clearly given that area is 4 centimeters. So if area is 4 centimeters and RQ and RP are 2 sides of a right angle triangle where the right angle is at R. So it means that half into RQ into RP equal to 4. So you can find what is that area. That is 2 root 2 is RQ. So RP is also 2 root 2. Now a circle is drawn such that PQ is a tangent to the circle at S. R is the center of the circle. So R is the center of the circle means RS is the radius. So what is RS? This is RS. RS is the radius. So RS is the radius means this is radius. That is 90 degrees. Why 90 degrees? Radius and then tangent, that is 90 degrees. Now you can identify it. Now, in fact, how much is PQ? 4. 2 root 2 root 2. So if side is S in an isosceles right angle triangle, if the side is S, then the hypotenuse is S root 2. So 2 root 2 into root 2, that is 4. Then find the area of the shaded region. How will you find the area of the shaded region? It is fairly simple. You don't need all these things actually. You don't need that 4 also. You just don't need it actually. It is a right angle triangle, or like it is a quadrant. It is a quadrant. Now you should know what is the radius of that semicircle. So to find the radius of the semicircle, if you draw RS, RS is the radius and PQ is a tangent, so it is a tangent. Now half into PR into RQ is equal to half into RS into PQ. Now, how much? Two. RS is 2. So if RS is 2, now you can find the area of the triangle minus area of the quadrant circle. Area of the quadrant, to find the area of the quadrant circle, we know the radius. So area of the triangle minus area of the quadrant circle will give us shaded region. So remember, every single time, radius, tangent, chord, angles. Now, two circles C1 and C2 of the same radius are such that the circle C1 bisects the circumference of the circle C2. If the radius of the circle is 7 cm, what is the area of the common? What is the area common to circles? Solve on your own. It's a fairly simple one. You will find a surprising answer also. A circle of radius 2 cm touches another circle of radius 10 cm internally. Find the length of the tangent segment drawn from the center of the larger circle to the smaller circle. Same to same questions. Every single time. Radius, chord, tangent, that's it. So it means that whatever happened to this worksheet. So I cannot directly give a comment on geometry, but whatever happens in this worksheet, it is always radius, tangent, chords. So as if geometry circles is all about only these three things. So circle of radius 2 cm touches another circle of radius 10 cm internally. Find the length of the tangent segment drawn from the center of the larger to the smaller. So if you draw, then it will look like this one. This is the bigger one, this is the smaller one. So now we draw, this is, so this is 10 and then this is 2. That is the radius. This radius is 2. Now if I draw a tangent, so I need to find the length of the tangent. How can I find the length of the tangent? Look at this one. This one is how much? 2. So this is 90 degrees. Now if you draw a straight line, how much? 10 minus 2, because this is the radius. Now this is 10 minus 2, which is 8. This is 2. 8 square minus 2 square is the tangent. That is how much? 8 square minus 2 square, that is 60, root 60. Root 60 you can find 2 root 15. You can find the other way as well. It's even a simpler case. I'll solve the second case. Just observe this one. O, center, I write as A, I write as B. This is T. OT square equal to OA into OB. You know AB actually. How much is AB? 4. Because that is the diameter of the sun. How much is OA then? 6 actually. Because yeah. So that is OT square equal to OA, which is 6, AB which is
4.
OA into OB. OA is 6, OB is 10. So OT square equal to OT square equal to 60. OT equal to root 60. That's it. See, look at the flexibility. We have OT square equal to OA into OB. We have the other method where like you are going to use right angle triangle method. Both the things. Next one, in the figure given below, not drawn to scale, x degrees equal to. So even if it is drawn to scale, how can I calculate the length? Because I am not provided with the measurement scales. So what is the use of mentioning it actually? In the given figure, find the x degrees. Now if you observe all these things, before finding x degrees, let's focus on how to find x degrees. The first thing is, we know one concept we have already covered. We know that we have to go through the concept which is already covered. What is that one? Segment theorem. Segments actually. So now if you observe it actually, DBC is 30, CAD is also 30, OCB is 50, BDA is also 50. You can find it just like that because all these are segments only. I'll just draw this one table, or else I leave it to you actually. It's better if you solve on your own. So look at this one. If this is 50 exactly, AB is a segment. So from this ends, this is 50 degrees. It means that this is also 50 degrees. Now observe this one. This one is 30 degrees. That is DBC is 30 degrees. DC is the segment. It means that CAD is also 30. So this is 30 degrees. Now look at this one. In a triangle BPC, 30, 50 is given. So this angle is equal to 100. So now this angle is also equal to 100. So it means that the remaining angle, this is 80 and then this is 80. Now the next task is to find these angles so that you can find x degrees. So because to find that x degrees, I know that this side is exactly equal to 80. So if since I know 80, if I know angle PBA, then I can find x. So now I need to identify. Observe it carefully. You will find it out. Find it out. It's a simple one. You need to use that external angle. So do not blindly follow just like that writing every segment actually. Find that one, E. One more segment is missing actually. Now if you observe it carefully, actually BC, I take that BC as a segment. So it will be that the angle BAC equal to angle BDC. So angle BAC is given as x degrees. So angle BDC is also x degrees. Clearly this is also x degrees. Now look at this one. Angle D, that is 50 plus x degrees. Angle B, 30 plus some degrees. Opposite sides are angles of the opposite opposite angles are equal to 180 because it's a cyclic quadrilateral. Now you can find it out. Yeah, we focus on next question. Question number 14. In the figure above, A and B are the centers of two circles. The moment you look at the figure, AB is a tangent to the circle. So you don't have to do anything. In the given figure, A and B are the tangents to the circle of radii 9 centimeters and 2 centimeters respectively, such that length of AB equal to 13. So length of AB is clearly given as 13, and then radius of A and radius of B is given. So radius of circle A is 9, radius of circle B is 2. It means that the length between, so AB, that is the middle one actually. If you subtract the radius from 13, So it is going to be 2. Okay. Angle ACB equal to 90 degrees, where C is the center of another circle with such as the two circles. The area of the circle with the center C. So you need to find center C. How will you find? We need to find radius. Again, a right angle triangle is given. Hypotenuse square is equal to sum of the squares of the sum of the remaining two sides. So it means that CA square plus CB square. So what is CB? 2 plus radius of so radius is R. So this one is R plus 2. Now look at this one. CA is radius of one circle and radius of the other. So this is R plus 9. Now R plus 9 whole square plus R plus 2 whole square equal to 13. Now you can find it. So you'll come to know R, then it's down to, yeah. Next one. Two circles of radius 5 units each intersect each other as shown in the figure. The area of the shaded region so formed is how much? So we need to find the area of the shaded region. Remember, area of the shaded region is not in the shape of a geometrical figure. It is of course it's in shape of geometrical figure. It's not a common geometric figure. It looks like a curved shapes actually. So how will you find that one? Remember, why 60 degrees is given? Why not 40? Why not 50? How will you find? Yeah. Look at this one without finding it actually. This is 60 degrees arc. So you can find the area of the arc just like that. Now since it is 60 degrees, if you observe it carefully, this is O if I write, this is A if I write, this is B if I write, and this is O dash. Look at this one. OA, OB are equal and they are radius. And then this angle 60 means OA, OB is isosceles triangle, and if you find this one is 60 more degrees, these two. So it means that it is an equilateral triangle. So observe it. I have drawn an arc actually. I need to find the shaded region. If you observe it carefully, it's an equilateral triangle, and then subtract the area of equilateral triangle from the area of the arc so that you can find half portion of the shaded region. Remaining half portion comes to the other side, that is O dash is the O dash. With the O dash, that one you can find the same way. So it's a fairly simple thing. Find the arc with radius 60 degrees as the angle. So once you find the arc, you just need to subtract the area of the equilateral triangle. So that will give the half portion of the shaded region. Okay, you can find it out. It's just down to applying that how to find application part actually. Now let's focus on question number 16. Let's solve it. Again, look at these things: AB and AC, tangents. OB and OC, radius. Now, in the diagram, AB and AC are tangents to the circle with center O. Angle BAC is equal to 90 degrees. If BAC is 90 degrees, you can directly say that angle B is 90, angle C is automatically angle B and angle C are 90. It means that angle O is also 90 degrees. So, what kind of a triangle is that? What kind of a quadrilateral is that? It's a square. It's obviously because OC equal to OB, AC equal to AB. Now, let's read the remaining part of the question. Find the radius of the circle which touches the given circle at P such that AOP and AB and AC are also tangents to the circle. Given radius of circle with the center O is 3 minus 2 root 2. AOP and AB and AC are tangents. That is not at all possible. AOP. What is AOP? So AO is what? It is the diagonal. So how can I draw a circle? So if I have to draw AB and BC as tangents, it means that I should draw like this. or else I should draw like this. That is a circle. But it is not possible for AOP to meet it or AOP to become a tangent to the circle. Anyhow, just leave that one. Seems to be a confusing one. I think AOP is supposed to be defined as a different one, I guess. Next, question number 17. In the figure, two circles intersect each other at point P and Q. Point A is on PQ extended and AMD and AS are the secants of the circle. If the length of AM is given as 3, MD is given as 5, AS given as 4, find the length of SR. How will you find? So this is one more concept that you need to understand. We haven't covered in that concept builder class actually. Concept builder video. So if you observe it, so there is a property. I just need to tell you two more things. Inside a circle, if two cards intersect like this, two cards, let's say this is O and it's AB and it is CD, then AO into OB equal to CO into OD. AO into OB equal to CO into OD. Two cards. Now one more property I need to cover. Okay, it's an internal one. So let's draw two secants from the same point. Let's say this point is AB, this is CD. Then PA into PB is equal to PC into PD. Now, to state this question, well, if you observe it, AM into MD equal to AS into AR, simultaneously AP into PQ equal to, so all these things are sequence, right? So it means that AM into AD is equal to AP into AQ, that is equal to AS into AR. Now you can find all of them. We just move to question number 19. Looks like a big one. Solve it quickly. So what is the answer for question number 18? Read question number 18. A circle is drawn with a radius r units and center O. Length of OA equal to 4r. So it means that you can find that remaining part. Okay. Length of OB is again given as 3r. And angle M, measurement of angle AOB is equal to 60 degrees. Then what is the area of the shaded region? What is the area of the shaded region? How can you find? Is like you need to remove the circle from the shaded region. What is the shaded region? Shaded region in the form of triangle. How will you find the area of the triangle? It is, if you know all the sides, we have a different formula. If you know only one side, then the height, we have a different formula. Here we have a formula by using angle, that is half into sine 60 degrees into length of OA into length of OB is the area of the triangle. So once you find the area of the triangle, you just need to subtract the area of the small circle. Small circle area, how can you find? Now one more thing. One thing is like tangents are given. So by taking out, then you need to find the tangent. So how will you draw this one? It's like I'll just let me draw. Let me draw. Let's say I draw a polygon. Okay, this is how it is. So I need to find this one. Come to this one. This is radius. This is tangent actually. So the moment you find the tangent, it's even simpler. Now, if you draw like this is 90 degrees. Since it is 60 degrees, it is bisected and it is 30 degrees now. It is 30, then it is 60 degrees. So if you just say OAB, O dash C. So then observe it. O dash C is the radius of the smaller circle. Then you can find 30, 60, 90 degrees triangle. So 30, 60 degrees, 90 degrees triangle sides are in the ratio 1 is to root 3 is to 2. 1 is opposite to 30, root 3 is opposite to 60, 90 is opposite to 2. Now, I just need to compare that OC. What is OC? Opposite to 30 is R, so OC equal to R root 3. Then what is OC? How much is O dash? 2R. So OR is 2R. The next point O dash to this point is, this is R. So it means that the radius is, okay, whatever is there, the whole thing is 3R. Now you can find it out, then it's a simple process. Now from this point onwards, with just comparisons. Just focus on what is the information given here.
This is a polygon.
Just focus on it. Next question. It's a set of questions actually, 19 and 23. The same information for question number 1923. Read the information given below and answer the questions that follow. In the above figure, A and B are the centers of the smaller and the bigger circle, respectively, and AB equal to 6 centimeters. Both the circles meet internally at point P. The radii of the bigger and the smaller circles are in the ratio 5:3. Also, PR, the length of PR is given as 25 centimeters. Now, what we know is B is the center of the bigger circle, A is the center of the smaller circle. So, what is the radius of the bigger circle? BP. What is the radius of the smaller circle? AP. What is the ratio of their radii? So, that is BP divided by AP. They are in the ratio 5:3. So, 5/3. Now, however, you know BA length actually. What is BP? BA minus AP. What is BP? BP minus, what is BP? BA plus AP. BA plus AP. How much is BA? 6. BA 6. What is AP? Radius of the other one. They are in the ratio 5:3. It means that now you can find it out. BP minus AP is equal to 6 centimeters. BP and AP are in the ratio 5:3. You can say that 5x is to 3x. So these are in the ratio 5x is to 3x. Now I know BA. I know BA. What is the BA? Now you can find it out. So that is 5x minus 3x is equal to 6. That is 2x is equal to 6. X equal to 3. X equal to 3 means 15:9. So that is 15 and then AP 9. Now what should I find? PR is also given. PR. What is PR? Chord of the larger circle and then secant to the smaller circle. Now find the ratio of the lengths of QR. How to find QR? How to find QR? Observe. You should apply the concept that you have already known. Just apply them. Find the length of QR to that of PR. So what is QR here? Just focus on it. Focus on it. You are going to get it actually. It's a fairly simple one. So you should use that one actually, 6. So we know the radius also. What is that one? Yes, you got this one. I told you that you should apply the concept you have known actually. Now, look at this one. If you join this TR, PTR is a triangle. And what is PT? Diameter. So it means that this angle is 90 degrees. Now I know PT because I know BP. BP is 15. PT is the diameter, that is 30. I know PR. Now I can find TR just like that. Once I find TR, then it is a matter actually. Focus on it actually. So you can join SQ also. So what is SQ? Again, SQP is a right angle triangle. TRP is a right angle triangle. Once you know this one, you can find this one. So how much is TR? How much is TR? That is, what is the length of PR? So that is 25. What is the length of TP? 30. 30 square minus 25 square. So you can find TR actually. Next one. What is the length of SP? SP. SP is the diameter of the small circle. 18. So you know 18 actually. Now you need to know QP because this is also 90 degrees. Just find it out, find it out. It's simple things actually. Or else you can focus on it actually. PS by SQ equal to PT by TR. Just always follow the similar triangles. PS. What is PS? 15. 18. 18 divided by SQ is equal to 30 divided by TR. TR is how much? That is 30 square minus 25 square. How much? Root over 375. Root over 375 you can take it out actually. So just compare. So there are so many ways to find it out actually. Okay, next find the radius of the bigger circle. We have already known. Find the length of QS. Well, you can find it out. So remember, we are trying to apply. You should apply what you know actually, what you have already learned. So 19, 20, 21 are simple things actually. Now focus on 22. 2 chords of the length. Again, chords are given. 12 and 16 centimeters of a circle of radius 10 centimeter are perpendicular to each other. Find the distance between the midpoints of these 2 chords. Just imagine, chords 12 and 16 length. They meet at a right angle triangle and the radius is 10. So you should use the radius actually to find. Fine. So this is the circle. So I've drawn one card. I've drawn another card. So this is 90 degrees. What is the length of the cards?
16 and 12,
12 comma 16. So it means that if you take this is 12 and if you take this as 16, what is the radius? 10. So it is now. Now you need to use that radius actually. Use this one. Just apply that radius. How can we use radius here? We must use that radius actually. That is our logic actually. And why should they give it as 90 degrees? That means that is also a logic actually. Just apply it. That's a simple one. So we need to find that. Let's say this is the midpoint, this is the midpoint, this length. How to use that radius 10? Yes, you people are right. Got it? Use radius carefully. Use radius carefully. Next one, question number 23. Some triangles are given. OB, OA seems to be radius, everything if O is the center. In the given figure triangle, OBC is an isosceles triangle. The base CO is produced to meet the circle at D if measurement of angle ACD is equal to B. Measurement of angle AOD is equal to A such that A equal to K times of B. Then the value of K. We have solved the same question actually. Since isosceles triangle OBC, look at this one. If this is X, this is also X because OA. Now, this is 180 minus X. Now, BC and OB are same. So this is X by 2, this is X by 2. These two are X by 2. Yeah. X plus Focus on it. Just focus on it. Okay, got it? How much? Yeah. Next 24. ABCD is a regular hexagon of side 6. Find the area of the shaded region. So we just need to find the area of the shaded region. And it is clearly given that it is a hexagon. Shaded region area. So the one clue given here is it's a regular hexagon. It means that the side angle is equal to 120 degrees. So by using it you can solve. Check this one. The whole thing is 120 degrees. However, it is given as 90, so it means that angle CBD, this part is equal to 30 degrees. So if that part is 30 degrees, then you can find it out. 30, 60, 90 degrees right angle triangles. Thirty, 60, 90 degrees triangles. Find it out. It is even simpler if you remember these things. I told you, if there is an equilateral triangle, if this is 60 degrees and this is also side, this is also right, then this is also side. If it is a right angle triangle, if this is S and S, this is going to be S root 2. If it is a 100 degrees triangle, that is ABC. If this is S, this is going to be S root 3. Now, this S root 3 is an important one here. Observe these things. This part is a triangle with 120 degrees as the angle. Next one. This one is a triangle with 100 degrees, 120 degrees. Now the remaining two things are in the ratio. Remaining two circles are 90 degrees is 1/6. See, now you can find that whether it is 90, 45, 45, 90 or 30, 60, 90. So what is the area of the triangle? That is half into sine 120 degrees into side AB into side BC, that is 6 and 6. So sine 1 half into sine 130 is 120 is how much? Sine 120 is root 3 by 2. Half into root 3 by 2. So this one you can find that the area of ABC is equal to, how will you find? I told you just now, half into sine 120 degrees into BA into BC, that is 6 into 6. Now you can find it out. Now once you find this one, then you need to identify this one. This one is also side actually. This is a side, this is 90 degrees. Then you can find. Two equal circles with centers O and O dash cut each other at the two distance points C and C dash. If neither O nor C falls within the intersection of the circles, what is the smallest range that include all the possible values? Two circles cut out each other at two distant places at C and C1. If the neither O nor O falls within the intersection of the circles, so it is clearly defined actually. Zero to 0 to 240, 0 to 360, 0 to 180, 0 to 120. Question number 25. It is supposed to be a simpler one. Question number 25 is simpler only. Equal circles O dash, they intersect at C and C dash. If neither of O and O dash falls within the intersection of the circles, then what is the smallest range that includes all the possible values of angle CO C dash, angle C O dash C1 C dash. Two equal circles, it means the same, right? Just draw this one. What is the question? Two equal circles? Yeah.
Each other, let's see C dash, such that O dash doesn't come in the area of intersection.
Now you can find it out. Solve, this is a simpler one actually. You can find, you are going to use the tangents only. So CO C dash, C CO C dash. Next one. Next one, CO C dash. CO dash. These angles. That's just a simple one. OC is a tangent, so it is 90. This is also 90. Now what happens to these things? Then 180. Yeah. Question number 26. Solve question number 26. Question number 26. In the figure given below, AF, BF, BE, CE are straight lines. If the points A, B, C, D are concyclic, what is the value of y minus x? So concyclic means opposite angles are equal to 180 degrees. So now you can say that angle y equal to 58 degrees. So if angle y equal to 58 degrees, then you can find what is angle C, that is angle FCD, because if y equal to 58 and the f is also given, so 58 plus 32, that is 90. So angle C is 90. Since angle C external is 90, angle C internal inside the circle is also 90 degrees. So now EBC triangle, one side is 90, other side is 58, and it means that angle E is 32 degrees. So now y is 58, E is 32. So y minus, yeah, that is 26. Next one. In a circle, the distance between two parallel chords of the length 6 and 8 centimeters is 7 centimeters. The two chords are on opposite sides of the center of the circle. What is the circumference of the circle? This type of question is directly, it is just a modified question. It is the original CAT question, but just modified by taking different numbers. It is the original CAT question. Two chords, the lengths of them are 6 and 8. The distance between them is 7 centimeters. If the chords are on opposite sides of the center, what is the circumference of the circle? Circumference of the circle, to find the circumference of the circle, we need the radius. So circle, on opposite side, one is 6, next one is 8 is given. What is, and the distance between these two is 7. Now, how much is this one? 6 centimeters. How much is this one? 8 centimeters. Since it is the point, actually, this is the midpoint. So it means that this length is 3. This length is 4. Now, what is this length? This length is 7. Now, how do you find? Observe this one, 3, 7, 4. If you observe this one, it looks like a right angle triangle kind of a properties. Now, we need to find that radius actually. But radius, this one is radius, this one is radius, this one is R, this one is also radius R. Now, what is 6 actually? That is a chord, a line drawn from the center to chord. It bisects. So, it is 90 degrees. These are 90 degrees. It means that this part is 3, this part is 4. Now r square minus 4 square equal to, let's say this one is x actually, this one is 7 minus x. So r square minus 4 square equal to x, r square minus. So that is like you find it as 3 and 4. 3 and 4. Now if you find that it is 3 and 4, what is radius? 5. That's it. Question number 28. In the figure given below, AB is the diameter, so immediately E is 90 degrees. If AB is parallel to CD and AC is parallel to BE, angle BAE is equal to 35 degrees. Then the absolute difference between angle CDB and angle ABD, these are just simple questions actually. This is a simple question. Solve. So since angle E is given, angle A is, since angle BAE is given, we can find that AB is also, because E is known. So angle ABE is 55 degrees. Now you just need to find ABCD. ABCD is a cyclic quadrilateral. So angle C plus angle B equal to 180, angle A plus angle D equal to 180. How much? How much? Just find it out. Well, you can solve this one question by taking some additional lines also. You can draw CB, you can draw DA. It's a polygon, a regular polygon, or it seems to be a regular polygon where the sum of the inside angles are equal to 540. No, 540. See, if you take one side, three sides, it is 180. If you take four sides, you add 180, one more 80. That is 360. If you take one more side, it is going to be, you need to add one more 180. It'll increase. Fine. It's a simple one. Just next, focus on 29. ABCD are 4 points on the circumference of a circle such that DC is the diameter of the circle. The point of intersection of O of AC and BD lies the circle. If angle ACB equal to x, angle ABD equal to x minus 10 degrees, and angle BDC equal to x plus 10 degrees, then measurement of angle DOC. Draw the figure. So we need to draw TC as the diameter. Well, polygon. What is this question? DC is the diameter. Okay, I have written as. So angle ACB equal to
x2
x degrees. Next one,
and ABD equal to x minus 10
ABD equal to x minus 10.
and then BD is equal
So angle BD is equal to x plus 10.
to 10 degrees.
Now just apply that segment once. Take BA as segment, CB as segment, CD as segment, AD as segment, then you can find it out. Yes, just take the segment, then you can find. You can write that this one is this one will become. If you take AD as the segment, then this is going to be x minus 10. If you take BC as segment, then this is going to be x plus 10 degrees. Now angle A plus angle C equal to 180 degrees. So this angle is going to be 180 minus x minus 10 minus x minus 10. So that is 180 degrees. This one is 180 degrees minus x minus 10 plus x plus 10. So that is 180 degrees minus 2x. If this is 180 degrees minus 2x, this is going to be 180 degrees minus 2x. It means that this is going to be 2x. This is going to be 2x. This is going to be 180 minus 3x. It means that segment CD, this is going to be 180 minus 3x. So now x plus x minus 10 plus x plus 10 plus 180 minus 3x equal to 180. Now you can find it out. Well, yeah, these are simple things. You should not focus on them. These are going to give you the sure shot answer. Next one. The quadrant of a circle of radius 12 is cut out from the remaining part, and the remaining part is folded to form a cone. Find the surface area of the cone. Simple question. mensuration related question. I am not going to teach you now. Simple question. Mensuration, you can solve it. 3 circles, each of radius 20, have centers PQR. Further, AB equal to 5, CD equal to 10, EF equal to 10. What is the perimeter of angle PQR? This is a simple one actually. 3 circles, each radius are given, have centers PQR, where AB is given. What is AB then here? So this question 31, it was question number 1 of different set actually. So leave it actually. This question is not for this one. Solve question number 32. A certain city has a circular wall around it, and this wall has 4 gates pointing north, south, east and west. A house stands outside the city 3 kilometers north of the north gate, and it can just be seen from a point 9 kilometers east of the south gate. What is the diameter of the wall and the wall that surrounds the city? I think you are going to get a right angle triangle here again. So there is a city. A city has circular one. So from this one, at a 3 kilometer distance, there is a village. This can be seen from here, 9 kilometers. It means that you can draw like this. This one is 9. So if you want, this one is R, this part is R, this part is R. R plus 3 whole square plus R plus 9 whole square is equal to okay, 9 kilometers east and south actually. So I have written in a different actually. So house stands outside the city 3 kilometers from north of North Gate. Okay, and it can just be seen from a point 9 kilometers east of South Gate. Okay, I haven't seen actually. East of South Gate. What is South Gate? This one. So east side is this. East of South Gate. This can be seen from 9 kilometers. So it means that from this point it is 9 kilometers. This can be seen from this point. It means that it goes like this. Now what is asked here? Diameter of the circle. Now how will you find? So you can draw like this. Yeah, Pythagorean triplet. So that is 9, 3. If you want, you can take a Pythagorean triplet also. Or else you can say diameter, that is 2r plus 3 whole square plus 9 square is equal to, now you can find the hypotenuse. Observe this one carefully. This 9 up to this point, it is also 9 because this point is tangent actually. So solve it. If you need additional information, check the question. If any additional information is given. How much? Diameter of the wall. This is R. Now still you can find. This is exactly R plus 3. So R plus 3 whole square minus R square. You will get that value. How much? 9 వచ్చిందా? Okay. Or else just compare them. Isos, you can compare them actually. So compare them actually. I just write ABC, DE. Which two triangles are similar? AED and ABC. AE and ABC. So R plus 2R plus 3 by 9 equal to, or else just focus on it. R plus 3 by R equal to 2R plus 3 by 9. Antena? Just focus on it. 33. Lengths of the common chord. I am not going to solve this question. This is a simple one. There are two concentric circles such that the area of the outer circle is 4 times the area of the inner circle. Let ABC be the three distinct points on the perimeter of the outer circle such that AB, AC are larger or tangents to the inner circle. If the area of the outer circle is 12 square centimeters, then the area of the triangle ABC would be. Draw. Area of the outer circle is given as 12 square centimeters. So pi r square equal to 12. Then the area of that one. So if it is 12, then the inside area is going to be 3, right? 2 constant, 4 times the area, so then it is going to be 3. So this is 34. Now we are solving simple questions actually. Next, 35. Question number 35. Yeah. before this one, I'll teach you some how to divide that quadrilaterals and all, or how to divide this hexagons. So if you take this hexagon, what is hexagon? Hexagon is a combination of 6 equilateral triangles. It's a combination of 6 equilateral triangles. Now, the moment you find that 6 equilateral triangles, if I write that A, B, C, D, E, F, what is the length of FC in terms of AB? 2 times actually, because that is the longest diagonal. Simultaneously, BE as well as AD is also, yeah. Now, according to the midpoint theorem, if a line is drawn passing through this one, so that is like if a line is drawn passing through the midpoints, then this midpoint one is like, let's say that I write as M and N. Mn is half of FO. Let's say if I write here FO. What is the area of EMN to EFO? Squares of the ratio of the sides. That is Mn is half of FO, so that is 1 and this is 2, so that is 1 square, this 4 actually. Now you can divide that triangle like this. So if you just want to concentrate, let's say I have drawn from middle actually. So now you can draw, these 4 are equal. So if you draw from 1/3, then you can draw from 2/3 as well. So this is 3, this is 5. So it means that this is going to be 1, this is going to be 3, this is going to be 5. If you add that extension, it is going to be 7, next one is 9. So all these are odd numbers. Now we apply this one here. What is the question? Yeah, hexagon. Okay. So this one. Now, if at all, let us say a question is asked like this. If at all you come across a question like this. What is the ratio of the shaded region to the original hexagon? Where this one is like I'll write as M and N. M is FE by 2. I'll write this as N. N is DN by 2. Yeah, DC by 2. So it means that these two are equal. These two are equal. Now you can divide them. 7. So double. This one is 7. This one is 7. So how many triangles are there in the shade? 1, 2, 3, 4, 5, 6, 7. How many total triangles are there for every triangle? That is exactly 4. 4 into 6 triangles, 24. Out of 24, 7 are shaded. Now I just concentrate on the previous question. This question only. Now this angle is 90 degrees is given. If you observe this one, this is the combination. What is happening? That one is exactly half of one triangle. How many triangles are there? 12. 6 triangles are there. One triangle is halved. So it means that now you can find like this. Out of 12, just one. So 1 is to 12. Solve question number 36. Yeah, we have already solved question number 36. Now let's focus on question number 37, 38, 39. 37, 38, 39. Yeah, some information is missing here. Actually, P, Q and QO are given, whereas in the figure P and Qs are not given actually. I'll just read this question. In the adjoining figure 1 and 2 are circles with P and Q respectively. The two circles touch each other and then have a common tangent, and that touches them at a point R and S respectively. This common tangent meets the joining point of PQ at O. The diameter of 1 and 2 are in the ratio 4:3. It is also known that the length of PO is 28. Okay, information is not given. I can write, but it is still okay. You can leave it actually. But if we want, then I'll, since there is no point in trying to leave this one, I'll just write this one. So this length is given as 21, this one and this one. That is this one I called it a radius 1 and this one is radius 2. They are in the ratio 4:3. So you need to find this one. How will you find? Yeah, this angle is common. Since it's a tangent, this angle is 90. Since it's a tangent, this angle is 90. Now you can compare the similar triangles actually. If I take like A, B, C, D, E, you can compare ABD to ACE. So if you compare them, then you can find that AD length and then DE length and then AE length also. That is a simple thing. That is you can focus on. 39. 40th. A circle with radius 2 is placed against a right angle. Another small circle is also placed as shown in the adjoining figure. What is the ratio of the smaller circle? How do you find this one? Now, just draw a point from here. What is this one? This is radius. What is this one? This is also a radius. Now, what is this one? Yeah, 2√2. That is a diagonal. So, side is 2. This one is 2√2. So, that the diagonal is equal to 2√2. But however, diagonal you can write as, that is radius is R. Let's say I write the radius as capital R. Plus, look at the inner one actually. Inside one is also a triangle actually, where you can write like this. So this one is smaller √2. Okay, what is this total length? It is 2√2. That is called R plus smaller √2. Now you can focus on them actually. 40th. What is the distance? 41. What is the distance between two parallel chords 32 and 24 in a circle of radius 20? What is the distance between? See, you know how to solve this question, but careful. What is the distance in centimeters between two parallel chords of 30 to 24 centimeter in a circle of radius for 20? Are they on the same side of the triangle or they on the opposite sides of the diameter? So you should. So if they are on the same side, you will get a different distance. If they are on the opposite sides of the diameter, you get a different one. So this question is a simple one. You should not solve it actually. Yes. Question number 42, question number 43. A semicircle is drawn with AB as its diameter. From point C of points on AB, a line perpendicular to AB is drawn meeting the circumference of the semicircle D. Given that AC equal to 2, CD equal to 6, what is the area of the semicircle? I just write that one. This is like this. AB, from a point C on this one, a perpendicular is drawn. So this one is given as 2, CD is given as 6, and they have asked us to find the area of the semicircle. So to find the area of the semicircle, we need radius. Observe, you are going to apply radius, tangent, chord. How much? Use radius. Use radius. If you use radius, you find it. See, if you want to find the radius of a triangle, radius of a circle, where some information is given, how will you find is like you need to form a geometrical figure. The better geometrical figure to find is always triangle. So now, if you want to find that one, so now, yeah, that is like this is the radius. How much is this one? OC R minus 2. Now, R square is equal to 6 square plus R minus 2 whole square. Then you can find that R actually. Every single time, whenever you come across any question, every single time you are going to apply the concept that we have already covered. And these are simple concepts, we have already learned them in our 8th, 9th, 10th standard. Now finally, 43. We have already solved this question actually. 43 also come actually. Now, see, observe these things. The most important things are 30 degrees, 60 degrees, 90 degrees, 45 degrees, 45 degrees, 90 degrees, chord, secant, tangent. These are very important. Every single time you come across, try to apply these things. Okay? Yes. So we have solved a major portion of major part of geometry. Then in the next video we cover quadrilaterals. In the following videos we'll cover mensuration and a mixture of all the geometry areas. Thank you.